Welcome to his Creek Workshop. My name is Yuchel. A couple months ago, I picked up this Dormer shell mill from Amazon at a pretty good discount. Well, today we're going to make an arbor for it. But before we get started, we received a couple stickers from other YouTube creators. First is Anthony. He has a cool channel called Ragsdale Creek Workshop. And Dean in California, the Air Cave Shop. They're pretty cool channels, very nice guys. Be sure to check them out. This is Dormer D40050.0 shell mill. Basically, it is 400 millimeters and it is made of cobalt high-speed steel. Now, I picked this up on Amazon, but I noticed after I purchased it, I noticed how expensive these were. These are going for around $300, and I don't know why. It's about 1.5 inches tall. It's made in Italy by Dormer, and like I said, around $300, and I guess that must mean it's really good. I purchased this from Amazon for $34. They had a quantity of one, so this was the last one. Maybe I guess they were trying to clean out their inventory and make room for something else. But anyway, $34, not bad. So this is the one that we're gonna make an arbor for, and we'll go to the computer and I'll show you the modeling that I did. All right. So I'm starting to teach myself how to run Fusion 360. So this is the arbor that I designed. It took me about 3 hours to get to this far because I don't know what I'm doing. You can tell it's not finished. I was trying to figure out how to draw the pocket for the drive tanks. So I was struggling with that, and I called Randy Richard because he's the Fusion 360 master. Say, hey, Randy, help me. How do I do this? Well, he helped me, and he did this in like matter of 5 minutes. So let's take a look at this one. All right, so this main portion here is 3/4 inch straight shank. Here is, what did I say? 22 millimeter diameter, and it's metric because the cutter is metric. And 19 millimeters in length right there, but it can be plus minus 1 millimeter. It really doesn't matter. And right here is just an arbitrary diameter. I selected 30 millimeters. And here's a pocket that is, what is that? 10 millimeters. And protrudes inwards 10 millimeters, and the tank will stick out 6 millimeters. And the opposite will have the same feature. So, like I said, I'm very new to Fusion 360, and I hope to start incorporating more of Fusion 360 in future projects, and whenever it warrants it. I also just got a 3D printer, so I'm teaching myself how to do this anyway. So it'll help better demonstrate what I'm trying to make. So let's head over to the shop and start machining. And I have this piece of 4140 annealed steel, round blank. We're going to make it out of this. We're not going to heat treat because then it'll change the dimensions, and I just don't have the capability to do cylindrical grinding, and I don't think you need that. I don't think you even need this type of material, but that's what I have and we're gonna use it. All right, peeps, we're gonna turn down the shank portion first. Like I said, it's gonna be 3/4 of an inch. Allergies, man, sucks. Anyway, 3/4 inch diameter shank. I'm gonna machine it long because I have a project coming up in mind where I think I'm gonna need that extra shank. But we may shorten it. We can shorten it anytime we want. Anyway, I'm gonna use up my cheap Chinese insert, the last one that I have. Let's get going. I think I'm at 910 RPM or something like that. Finish is not bad. Anyway, maybe I should explain why I'm machining the shank first. It's really important that I maintain concentricity relative, between the shank and the portion that's going to hold the shell mill. And the portion that fits in the shell mill is only 19mm length. So if I machine that portion first, I'm going to be trying to grab onto that little material while I machine this shank, and it's just not the most rigid setup. So I'm going to turn this down. I'm going to turn down the body portion here a little bit so I can register, and we'll flip it. Alright, let's keep going. Well, that's not good. That insert is not breaking chips very well. You know what? I'm going to say goodbye to that insert. I'm just going to swap it out right now. A lot more manageable. Nice blue, taking the heat out of the material with it. That is Mitsubishi CCMT, whatever that is right there. A little warm, but nothing to worry about. Let's see, how are we doing? We're about just over 1 inch. Let's crank up the RPM now to 1280. Yeah, I don't like that RPM. Let's go back, slow it down a bit. We'll wait till we get smaller in diameter. No, I'm curious how different geometry inserts do. Let's swap it out. Just curious. Getting a little hot. Let's let it cool off. We have about 140 thousandths to take off. A bit more to go. I took a lighter cut to see how the finish is being affected. You notice something? I didn't notice this. Let me show you again. The center is not turning. Earlier this part was hot, so it pushed it, and now it cooled off and shrunk. The center wasn't making a contact, and I didn't notice that. There you go. $7.86 and 4/10. So we need to take off 36.4 thou. Just gonna go for 37. These inserts seem to like about anywhere between 40 and 60, well, about 30, 40 I should say. So it looks like I came a thou under, and that's alright. Now we're gonna clean off the surface right here. Camera, there you go. Clean off the surface. Well, I'm gonna clean off this face here first, and then clean off a surface so we can register when we flip it over. Alright. Let's chamfer that end a little bit. Okay, so we got the part flipped. Let's just see how well we registered. Oh, it's right on. That's good. Love this chuck. Okay, so this portion of the arbor needs to be 22 millimeters in diameter to fit through the center of the shell mill. See, we want to leave 22 millimeters about. Wondering if that's too much. Maybe take 5 more millimeters higher. We're designing as we go. I think I want to let it cool off a bit first. Okay, a few more cuts and we can dial it in. Ooh, close, but doesn't want to go in. $866.5. Yeah, it's like 4/10 too big. I'm gonna take it out with emery cloth. But I'm gonna clean off the corner there, clean off the face there, and machine a relief. That needs to be, where's my other scale? Only 19 millimeters. I got a little too long. Put a light chamfer on that. Ooh, cooled off just enough to fit. Look at that. Perfect fit. Okay, now we gotta take the outside diameter here down to 30 millimeters. It's not a critical dimension. Again, it's just a shoulder for the shell mill to sit on. .213. 32 thou off. See, it got warm just enough for it to not fit again. That's a good fit. Oh, there it goes. We're gonna drill and tap for a 1/4-20 at the end. It'll hold the washer in place. That'll retain the shell mill. Quick bottoming tap. We're gonna make a washer that goes at the end, right there. It's not gonna be visible anyway. There you go. We're gonna drill a clearance hole. To the face of the chuck. Boom. There it is. Let's make it 3/16 of an inch. So we're gonna leave a little meat for cleaning. Oh yeah, I didn't drill the hole deep enough. That's alright, we'll clean it up when we face off the other side. So I used a set of parallels to set this out towards the end of the jaws. You just put one parallel between the two, on top of the two jaws, and put the other one, hold it up there, tight against the jaw parallels, and tighten it. Alright, we're gonna have to finish drilling that hole just because I messed up. So we have the main portion of the Arbor machined, fitted. Washer has been machined. It's in there nice and tight. Now we need to machine pockets, one on each side, for a drive tank to be mounted that fits into that slot of the shell mill. Now that is a 1/4 inch end mill, and the slot we need to make is 10 millimeters, so more like 10.5. So we're gonna have to step over around 73 thousandths each side and widen that. Okay, now we'll just flip over and do the other side. Well, there it is. Pocket machined out. Pocket machined out. I get a little too close to the round portion here, but that's alright. It won't hurt anything. I'm going to leave it on the collet block so later I can come back and drill and tap the holes. I'm going to machine the tangs now. Alright, turned out alright. Now we're going to have to round over the two corners on top. Unfortunately, I don't have a round over end mill, so I'm just going to have to go to the sander and spend some quality time there. I'll be back. Let's drill and tap for the tangs. Trying a new tap. It's from Amazon. It's around 10 bucks, I think. It's working pretty good. Makes long stringy chips and pulls it out. So it would work well on blind holes too. Pretty nice tap. Made in Korea. Whoa. Probably my cousins over there probably made these. Alright, let's put this together. The Arbor came out good. I quickly took a file and deburred around those pockets. Those screws just hold this in place from, prevent it from coming out. But all the force is going to be the twisting motion, and the pocket itself will take all of that. It's pretty darn sharp. And the screw and the washer, all it does is keep the shell mill from sliding out. Again, that doesn't take any of the force when you're actually using the tool. I'm really trying to be careful so I don't cut myself, as this thing is really sharp. There it is. One Arbor done. I'm happy with how it turned out. Like I said, I made that extra long because I have a project coming up where I need that extra clearance. So once I'm done with that, I may cut it off. I don't know yet. Well, that was a fun project. It wasn't particularly challenging, but, it was critical that we get those tangs in correct locations. So it turned out pretty good. Like I said, the shank's kind of long, but I have a project coming up where I need that, so you'll find out what I'm going to use it for. But here's a quick tip for you. These kinds of shell mills, or even carbide face mills, often come in these plastic containers. Once you put a shank on it, they don't fit, obviously. Here's a trick. Put them in there. Drill a hole on top. You can keep it in a drawer and let it roll around, and it won't chip the teeth or damage the cutting edge. And I want to say special thanks to Randy Richard. He sent me these custom printed 3D printed oil cups. That's probably him. With my Crick Workshop logo, I took a magic marker Sharpie and kind of painted it. And the other side has his shop logo, and it was a total surprise. Thanks, Randy. Thanks for watching. See you next time.